This is Unit 3, Matter Notes, Part 1. So the objectives of this unit is to be able to identify and differentiate between the three states of matter and their properties, such as solids, liquids, and gases. Differentiate between physical and chemical properties, intensive and extensive properties, and physical and chemical changes. So before we can identify and differentiate between the three states of matter, we need to know what matter is. So matter is anything that has mass and takes up space. So anything in this world and in this existence has matter. That is absolutely everything. Mass, however, is the measure of the amount of matter an object contains. So different objects can contain different amounts of matter based on physical appearances and differences, such as a golf ball versus a bowling ball. Which one do you think would have more mass? Well, I would think, and I know, a bowling ball has more mass because it has more space that it takes up as compared to a golf ball. A golf ball takes up less space, hence it has less mass. The three states of matter are known as solids, liquids, and gases, and you should be able to differentiate them between their shape, volume, expansion upon heating, and compressibility. So you need to write this chart down, the whole thing. So solids, they have a defined shape and a defined volume. So think about the pen or pencil that you're taking notes with, or the desk that you're sitting on, or the chair that you're sitting on. Does it change shape? Does it change its volume? No, because the molecular arrangement of a solid is completely packed down. So it does not change shape sitting on it, writing on it, or doing anything. It's going to maintain its shape forever unless we add any external heat or any source of energy to change that shape. And that is called a phase change, which we'll talk about later. When you try to expand it upon heating, it only slightly expands unless you add enough heat to physically change its state of matter down to a liquid, and again, that's outside this range. It is also almost incompressible, meaning you cannot compress down a solid any more than what it is due to its molecular arrangement that you'll see on a future slide. Liquids have an indefinite shape, but they do have a definite volume. That means if you have the same amount of liquid, it can take the shape of whatever container that it's in. So let's say we add 50 milliliters, so that's 50 milliliters to each of these containers. It's going to have a different shape based on the container that it's in. We're not changing the volume because it's maintaining the 50 milliliters, but whatever container that it's in, it takes that shape. Whenever you try to expand it upon heating, it's only moderately expanded. It's a little bit more than a solid, but not as much as a gas. That's because its molecular arrangement is a little bit wider because it has a little bit more room within the molecules. And then it is also considered almost incompressible whenever you try to compare that to a gas. Again, gases, they have indefinite shapes and indefinite volumes. That's because gases take the shape and volume of any container that they're in. Think about the room that you're in. If you try to go into the next room, or you go into your car, or you go into somebody else's room, gases take the shape and volume of any room that they're in. Whenever you try to expand it upon heating, it greatly expands because there's a lot of space in between those molecules. So I'm going to slightly draw the molecular arrangement at the very bottom. You'll see a more defined picture later on, but just to make everybody realize, solids are completely packed down, liquids have a little bit more room, and then gases are really, really far apart. Hence, you can easily compress them down. So when talking about solids, liquids, and gases, we can compare them through different phase changes. And I want to note that any type of phase change is a physical change. So any type of phase change is a physical change. And then we're going to define physical changes later on in this lecture, so just keep that in mind. Okay, so these molecular arrangements are a little bit better drawn if you want to take a look at the dots there, or you can take a look at the molecules or the atoms within the solid, liquid, gas bubbles over here. So if you look at the solids, they have a finite or crystalline leaf-like arrangement. So it's a fixed crystalline-like arrangement, and they are arranged in perfect rows and columns. That's because they are completely packed down to where they cannot be compressed any lower than what they are. It is a fixed arrangement. When you get to liquids, they have a more fluid-like type arrangement. That's because the molecules have spread out just a little bit. And then if you change that to a gas, then they are completely far apart and they're bouncing off everywhere. So then how do we change or go between solids, liquids, and gases? Well, if you looked at the graph or the chart, the X and Y axis, we are adding heat. Everybody knows that if you're trying to add heat to a solid, what's eventually going to happen? Well, it's going to heat up so much that it's going to hit a plateau here, and it is going to phase change into a liquid. So adding in enough energy and heat to a solid, you're going to melt it down into a liquid. So then it's going to consistently stay liquid until you get to a certain temperature. Then it's going to start phase changing. So vaporization is the same thing as evaporation. So it's going to phase change into a gas. So gases are at the highest energy here and at the highest temperature. So gases are the most energetic. They're the most energetic. That means they have a lot of energy. They're bouncing around. Gases are constantly moving. So gases are constantly moving. And if we try to go back in the other direction, we are taking out energy or taking out heat. So going down from a gas, if we were to cool it down, it would condense back into a liquid. So then we're condensing back into a liquid. And then if you keep taking out energy and you keep cooling it down, it's eventually going to get to a point where we're going to freeze that liquid into a solid. So by adding in heat or taking heat out, we are able to change or go between the three different states of matter. We're not chemically reacting the solid, liquids, and gases. We're only undergoing phase changes, so you can still have the same substance. For example, ice is a solid, or it's a solid H2O in solid form. If we heat that up enough, we're going to melt it into H2O, and that is liquid form. And then if we heat it up enough, it's eventually going to evaporate into H2O in gaseous form. So water can be or undergo phase changes to where it can be a liquid, a solid liquid, or a gas. Hence, water can be one of the three states of matter. So physical property is a quality or condition of a substance that can be observed or measured without changing the substance's composition. That just entails using our five senses to describe something. So when you physically describe any sort of piece of matter, you're describing what it looks like, what it tastes like, the sights, sounds, smell, everything. So depending on our five senses, we can describe. That is a physical property or a physical trait, such as appearance. If you tell me this can over here looks green, you are physically describing that can or that aluminum can. If you describe something and how it smells, such as odor, again, that is a physical property because you are not changing the substance's composition. You can also describe its hardness. You can tell me how much mass it has, how much volume it has. Then you can describe its density, which we'll talk about later. Melting point, boiling point, magnetism, and ductility, that's being able to be drawn through a wire. All of those are describing the physical properties of something because you are physically describing it. You are not changing its substance or what it's composed of because nothing is chemically reacting. So physical properties can be further divided into whether they are extensive or intensive. And you must know the difference between an extensive physical property and an intensive physical property. So let's first start with extensive. This is defined as a property that depends on the amount of material. So it is absolutely dependent on how much is there, such as mass, volume, length, or even this thing called moles, which is discussed in a later unit. But I want you guys to think about the previous slide that you saw earlier, where we had a big, huge golf ball. a big huge bowling ball, and then a little tiny golf ball. So we had a bowling ball, and then we had a golf ball. So think about it. We determined that the bowling ball has more mass because it has more matter, and that the golf ball had less mass because there was less matter. Okay, that depends on how much material is present. The more matter you have, the more mass you have. The less matter you have, the less mass you have. So the extensive absolutely depends on how much how much mass that you have. Going into volume, it depends on how much there is. There's a big difference between having a pool of water and then a tall glass of water. A humongous difference on the amount of material that's present. So again, extensive is dependent on how much material is in front of you. As compared to intensive properties, they do not depend on how much is present. So they are independent on how much is there. That means they never change. They absolutely never change. So let me just write change, never. They never change. So the property that does not depend on the amount of material, it only depends on the type. Again, so it does not depend on how much is there, such as boiling point. Okay, think about it. Water boils at 100 degrees Celsius. It doesn't matter if you have a cup of water, if you have a big long pool of water, or even if you have the ocean. Yes, there's other things inside of the water that make it boil at different temperatures, but however, pure H2O, pure distilled water, will always boil at 100 degrees Celsius. The more water you have, it might take longer to get to that 100 degrees Celsius, but water will boil whenever the entire volume that's there hits 100 degrees Celsius. So again, extensive properties, these depend on how much is present. If you change the amount of material in front of you, you change that property. Intensive does not depend on the amount of material. So all you have to do is remember, I for an I. Intensive is independent on how much is there. An important physical property that we're going to be talking about now is called density. This is the ratio of mass of an object to its volume. Hence, here is your density formula, and you can probably find this on your reference chart with all the formulas. This is an intensive property that does not depend on how much is present. So the density of each specific substance will never change. And if you take a look at the pictures down here, we have a couple of density values written. Again, it's a mass volume divided by a volume unit. So that's why you see the gram per centimeters cubed. Okay, so let's talk about density. Okay, we have lithium that's 0.53, and we have water that's 1.0, aluminum that's 2.7, and then lead that's 11. You see how lithium is less, quote-unquote, packed, while the lead is more packed down. So the more packed you are, the more dense, because 11 is a lot greater than 0.53. Lithium is the least packed, so then it is less dense. So think about it. The more small, tiny, and compact you are, the more dense you'll be. If you compare the density of liquids in a container, if you have liquids at the top here, the top layer, these are the least dense liquids, while the most dense liquids will fall down to the bottom. And on the next slide, we're going to use this density formula. So make sure you have this written in your notes. Okay, so a few density practice problems. For the first example, a copper penny has a mass of 3.1 grams and a volume of 0.35 milliliters. What is the density of the copper? So we're going to be using this formula, density equals mass divided by volume, which you should know how to calculate. So if density equals mass over volume, the problem is asking me, what is the density? So I'm looking for the density variable. So I don't have to rearrange my formula. I can just plug and chug my numbers. Well, if there's a mass of 3.1 grams, I have a volume of 0.35 milliliters. And if you plug that into a calculator, 3.1 divided by 0.35, you get 8.85 0.57, that is grams per milliliter for the unit. And I need to make sure I round to the correct amount of significant figures. There are 2 sig figs in the value 3.1. There's also 2 sig figs in the 0.35 because that 0 is non-significant. So I need to round my answer to 2 sig figs because it's dependent on the least amount. So I count one number, 2 numbers. The 5 would make the 8 round up. So my final answer will be calculated as 8.9 grams per milliliter. The second problem, you might have to rearrange the formula because they're asking you, or the density of dry air is 1.19 grams per centimeters. That should be cubed. Grams per centimeters cubed. What is the volume? So this time I'm looking for the volume of 50 grams of air. So when I said we're probably going to rearrange, you always start out with density equals mass over volume. I never want to calculate a variable on the bottom side or the denominator of a fraction. So I'm going to multiply both sides by the volume to cancel out the volumes on the right side. So now I'm left with volume times density is equal to mass. Now I can divide both sides by the density to cancel out the density on the left side. So to calculate volume, it's just mass over density. The mass is 50.0 grams. The density is 1.19 grams per centimeters cubed. Plugging that into a calculator, we get 42.0168 grams. And how many sig figs do we need in our final answer? Well, in 1.19, there's 3 sig figs. 50.0, there's also 3 sig figs. So you're dependent on the least amount because we're dividing here, so it's always 3. So then we have 1, 2, 3 numbers, make your line, and then 1 makes the 0 stay the same. So our final answer is going to be, that's wrong. Final answer will be 42.0 grams. So we talked about physical properties describing a substance without changing its chemical composition. That is different from the chemical properties, where a chemical property is the ability of a substance to undergo a specific chemical change that transforms it into one or more new substance. So chemical properties describe the ability of a substance to change into something completely different. So these can only be observed through a chemical change. So you're chemically changing the composition of something. You're changing what it's composed of. So whenever we talk about the ability of something to change, we're talking about potentials or abilities. For example, rusting. Rusting would be a chemical property of some types of metals. Burning potential, the flammability, that's able to undergo that change because fire will change the substance. It'll chemically change what it's composed of. There's also fermentation. We use that to make bread. And then also corrosion ability, another safety symbol. And also reaction ability. How reactive is something? Is it unstable? Is it just going to explode, go up in flames? So anything that describes something that's able to change or transform into something completely different, that is describing a chemical property. The last objective is to know the difference between a physical versus a chemical change. During a transformation of a physical change, the chemical composition does not change. They are considered reversible type changes, meaning you can eventually get back to what you originally had. So think about putting some sugar or some salt into a container of water. Okay, so that's my water, that's my salt. If you dissolve something, that is only a physical change because you are only separating out the chemical. You're not chemically reacting it. You're not changing what it's composed of. You're just dissolving it into water. So then you think about if you evaporate the water out, what do you end up with? You end up with a solid back. Also think about cutting a piece of paper. If you cut a piece of paper in half, did you change what you have? No, you're not changing what you had because it's still a piece of paper. It's just in smaller portions. So think about physical changes being kind of reversible, and also you're not changing what it is composed of. So more or less, any phase change, like your solid to liquid to gas, so you had evaporation, you had melting, you had condensation, you had freezing, all of those are considered phase changes because you're only physically changing the substance. Also, changing the position. If you move something from one place to another, you're only physically changing its location. So compare that to chemical changes. During a transformation, in a chemical change, one or more of the substances will change into something new, hence any chemical reaction. So go back to that piece of paper. If you cut the piece of paper, you're only physically changing it because at the end of the day, it's still a piece of paper. However, if you burn the piece of paper with fire, it turns into ash. Is ash the same thing as a piece of paper? No. Can you get paper back after you burn it? No. So hence, these are going to be considered irreversible changes because you cannot go back to what you originally started with. So then how do you know whether you've had a chemical change or not? Well, if you see color changes, anything like gas being produced, or you see the formation of a precipitate, that means a solid is coming out of a liquid or the reaction of liquids together, or if you see light or heat given off. All of these are indications of a chemical change happening in front of you. Have you accomplished the objectives? Are you able to correctly identify and differentiate between the three states of matter and their properties? Can you tell the difference between a physical and chemical property, intensive versus an extensive property, or even physical versus a chemical change? If you cannot, I would go back to the specific section that's giving you issues or trouble and then rewatch the video or take note and ask me questions in class.